SpaceX and Blue Origin have been competing with each other for many spacecrafts and commercial contracts. Both the companies are developing their next-generation rocket, but SpaceX as the leading space company has made many rocket engines since its launch in 2002. SpaceX has a goal to establish an operational cargo and crew architecture for missions between Earth and Mars, and possibly beyond, and Blue Origin also has same goal to make space for everyone. Achieving this ambitious goal requires a massive launch vehicle, with a cluster of high-powered engines, a propulsion system for operation in deep space, and a propulsive landing and ascent architecture for operation in the Martian atmosphere. All this will be realized by SpaceX's Raptor engine family. So how do the Raptor engines operate? Previous year SpaceX completed its 100th Raptor engine. This extraordinary milestone was achieved in just 29 months. A little over 2 years Blue Origin's rocket engines development started, work on the BE-4 engine since 2011. Importantly, they said the BE-4 would be ready for flight by 2017, but at this very moment Blue Origin's powerful BE-4 engine is more than 4 years late. The first flight test of the new engine is now expected no earlier than 2022. On the Vulcan rocket, this is a big problem and we need to talk about it. So how did Blue Origin's BE-4 turn into a joke, whereas SpaceX's Raptor is the leading example of the industry? Now, what is the difference between the Raptor engine and Blue Origin BE-4 engines? SpaceX's Raptor engine, the king of rocket engines. Let's compare SpaceX's open-cycle Merlin engine, that powers their Falcon 9 and Falcon Heavy rockets. SpaceX's full-flow staged combustion cycle Raptor engine, Blue Origin's closed-cycle, oxygen-rich methane-powered, BE-4 engine. That will power their new Glean rocket, which runs on hydrogen. The SLS is great, but what's maybe just as important when designing a rocket is the thrust-to-weight ratio, or how heavy the engine is compared to how much thrust it produces. First, how has BE-4 gone through almost a decade of failure? This was their first engine to combust liquid oxygen and liquefied natural gas propellants. It was initially planned for the engine to be used exclusively on a Blue Origin proprietary launch vehicle New Glenn, the company's first orbital rocket. However, it was announced in 2014 that the engine would also be used on the United Launch Alliance Vulcan Centaur launch vehicle, the successor to the Atlas vs launch vehicle. This was labeled a stunner choice. The company planned to begin full-scale engine testing in late 2016 and expected to complete the development of the engine in 2017. However, the first engine was not fully assembled until March 2017. Also in March, United Launch Alliance indicated that the economic risk of the Blue Origin engine selection option had been retired, but that the technical risk on the project would remain until a series of engine firing tests were completed later in 2017. A test anomaly occurred on the 13th of May 2017, and Blue Origin reported that they lost a set of power pack hardware. Blue Origin BE-4 rocket engine power head and combustion chamber was the first BE-4 engine to be hot fire tested. The test occurred on the 18th of October in 2017. Finally, in July of 2020, the first Pathfinder BE-4 was delivered to United Launch Alliance for integration testing with the Vulcan Centaur in August of 2020. But it wasn't remarkably by August of 2021, it had become clear even publicly that the BE-4 engine program was in trouble. Delays had been accruing in the program for 4 years, including turbo pump problems, combustion instability, overheating, and shorter than planned engine life. In addition, company management issues have left insufficient hardware to build development engines, leading to extended periods where no testing could be done, as well as issues related to company's CEO Bob Smith and the distraction of Jeff Bezos himself. Thus, Blue Origin has had difficulty getting the engines to run successfully at full power for a full duration burn. The company recently made the risky decision to ship the flight engines, currently not fully assembled, to their customer United Launch Alliance before they have completed full qualification testing, which delivery may still be last of 2022 rather than the earlier promised dates. The relationship with ULA has deteriorated in part mostly because Blue tried to renegotiate for a higher price in 2017 than had been agreed to in 2014. The BE-4 delayed development has increasingly been the subject of keen interest. This is partly because ULA has been working on its new Vulcan rocket for a number of years, and that rocket is important to the future of the company. The military is also eager for this delivery, is ULA is a primary provider of launch services to the Department of Defense. Alongside SpaceX, they hope Vulcan provides lower-cost launch services. With engines manufactured in the United States, finally many in the space community are genuinely curious about the cause of the delay, because of the launch services agreement. The U.S. military contributed $255.5 million toward BE-4 development. Money that comes from taxpayers, so the public has a right to know. Despite this widespread interest, however, Blue Origin has said almost nothing publicly about engine development. But during the time, what has SpaceX done? SpaceX first mentioned the term Raptor in 2009, but SpaceX only had a few staff working on the Raptor upper stage engine. At a low level of priority, they indicated quickly that details on a new SpaceX rocket would be forthcoming in the 1 to 3 years, and that the large engine was intended for the next generation launch vehicle. Using multiple of these large engines, that would be expected to launch payload masses of the order of 150 to 200 tons, which is around 330 to 440,000 pounds to low Earth orbit. Exceeding the payload mass capability of the NASA Space Launch System. Then in October of 2013, SpaceX announced that they would be performing methane engine tests of Raptor engine components at the John C. Stennis Space Center in Hancock County, Mississippi, and that SpaceX would add equipment to the existing test stand, infrastructure to support liquid methane and hot gaseous methane. Engine component testing. In April of 2014, SpaceX completed the required upgrades and maintenance to the Stennis test stand, to prepare for testing of Raptor components and the engine component. Testing program began in earnest, focusing on the development of robust startup and shutdown procedures. Finally, SpaceX successfully began development testing of injectors in 2014, and completed a full power test of a full-scale oxygen pre-burner in 2015. 76 hot fire tests of the pre-burner, totaling some 400 seconds of test time, were executed from April to August of 2015. SpaceX completed its planned testing using NASA's Status facilities in 2014 and 2015. By early 2016, SpaceX had constructed a new engine test stand at their McGregor test site, in Central Texas for Raptor testing by August of 2016. The first integrated Raptor rocket engine manufactured at the SpaceX Hawthorne facility, in California, was shipped to the McGregor Rocket Engine Test Facility, in Texas for development. Testing. It's the first full-flow staged combustion methalox engine ever to reach a test stand. It performed an initial 9-second firing test on the 26th of September in 2016. Until now, SpaceX broke ground a second production facility for Raptor engines, and that the facility will concentrate on the serial production of Raptor 2. While the California facility will produce Raptor vacuum and new/experimental Raptor designs, the new facility is expected to eventually produce 800 to 1,000 rocket engines each year. Incredibly, Elon Musk confirmed that Raptor production is approaching one every 48 hours. SpaceX aims at a lifetime of 1,000 flights for Raptor in 2019. The marginal cost of the engine was stated to be approaching $1 million. SpaceX plans to mass produce up to 500 Raptor engines per year, each costing less than $250,000. No one can deny that Blue Origin is definitely far behind. This only proves that the BE-4 is not how it was supposed to be, and no matter how many similarities it has with SpaceX's Raptor, it can't reach the level of the SpaceX rocket engines. Thanks for watching this video, and it's a super interesting topic. If you like this, make sure to subscribe. If you have any crazy ideas about what we should cover in next video, please comment it below, and we'll see if we can get to it. So thanks again for watching and goodbye.